Introduction. The rise of artificial intelligence (AI) is transforming software quality assurance (QA). Today's AI-driven QA agents can read specifications or requirements, generate unit UI API tests, keep those tests up to date as code evolves, and even file bug reports with detailed repro steps. These agents hook directly into a project's Git repo, CI/CD pipeline, issue tracker, e.g., Jira, and test framework. The promise is dramatic: more test coverage and faster release cycles with less manual effort. However, this new paradigm brings its own challenges, from flaky tests to AI hallucinations. In this article, we examine leading AI test generation and maintenance tools, their integration with development workflows, and their impact on coverage, flakiness, and cycle time. We also discuss dangers like tests overfitting to current code rather than true requirements, and propose strategies to ground AI-generated tests in formal specs. How AI QA agents work. At their core, AI testing agents aim to automate the manual steps of test design and upkeep. Instead of engineers writing scripts, an agent understands what needs to be tested from requirements and figures out how to test it from the actual application. The process typically follows multiple stages. Requirement parsing. Many AI testing tools begin by analyzing help documents or requirements to build an internal intent model. For example, Test Sprites agent reads your product specification, PRD, user stories, README, or inline documentation, extracting feature descriptions, acceptance criteria, edge cases, invariants, and integration points. These tools may normalize and structure the specs into an internal model of what the software should do. If formal requirements are missing, some agents can still infer intent by inspecting the codebase, e.g. routes, APIs, UI components. Test plan generation. Given the intent model, agents generate a test plan covering key scenarios. This might include writing unit tests for functions, API tests for each endpoint, happy paths and error cases, and UI automation flows, navigating pages, clicking buttons, filling forms, etc. For UI tests, the agent may open a real browser session to explore the current app, capture DOM elements, and record actions. Each test plan item often corresponds to a defined requirement or acceptance criterion, ensuring traceability. Test implementation. For each planned scenario, the agent writes actual test code in the project's preferred framework. Some tools use LLMs, large language models, or RL, reinforcement learning, to generate human-readable test scripts. For example, diffbluecover is a reinforcement learning engine that auto-writes Java unit tests. It can produce comprehensive human-like Java unit tests with all code paths covered. In one case, diffblue generated 3,000 unit tests in 8 hours, doubling a project's coverage, a task estimated to take over 250 developer days. Similarly, Shiplight AI's agent-first testing has chat-based coding agents write both the feature code and a corresponding test in YAML format in the same session. Every generated test is reviewed by humans for correctness and relevance and then saved into the code repository. Integration with workflow. A key advantage of these agents is tight integration. They typically connect to version control and CI systems, so tests run automatically on each commit or pull request. For example, ZOF.AI's agents connect to GitHub GitLab and generate tests on every commit. Framework integrations mean that when a new feature is merged, its tests are already in place and run in the CI pipeline as normal. This shifts testing left, embedding quality checks into development rather than at the end. Self-healing and maintenance. One of the biggest frustrations with UI test automation is maintenance. Element IDs change, layouts shift, traditional scripts break, often called flaky failures. Modern AI agents often include self-healing capabilities. They can, for instance, automatically adjust selectors or insert waits if the page loads slowly. The goal is that minor UI tweaks don't cause test failures. Shiplight's agent uses intent-based locators that adapt when the UI changes. ZOF's platform touts self-healing magic to update tests when the UI changes. No more broken tests from minor changes. More advanced systems like QA Wolf go further by diagnosing the root cause of failures, timing issues, stale data, runtime errors, etc., and applying targeted fixes rather than blanket fixes. In effect, the agent continuously maintains the test suite as the code evolves, keeping coverage high with minimal human intervention. Integrating with repos, CI, test frameworks, and issue trackers AI, QA agents are designed to plug into the existing DevOps toolchain. Code repositories. Most agents connect directly to a Git repository, GitHub, GitLab, Bitbucket, etc. They scan the codebase to understand project structure and insert test code as new commits. For example, ZOF AI's platform uses one-click OAuth to link a repo and then analyzes the code to understand your application structure. Shiplight's agent was built to work with AI coding tools like Claude Code or GitHub Copilot, so the agent shares the same workspace and Git context. Continuous integration. CI. Generated tests need to run automatically. Agents integrate with CI services, GitHub Actions, Jenkins, GitLab CI, etc., so that new tests execute on each commit. Tools often provide CI plugins or YAML configurations out of box. DiffBlue Cover, for instance, offers a cover pipeline that can be inserted into a CI flow to auto-generate tests on every build. ZOF and TestForge, among others, offer easy CI setup, so tests run on demand or automatically on every commit. Test frameworks. Agents generate tests in common frameworks, JUnit, PyTest, Playwright, Selenium, etc., so they fit your stack. For UI tests, the agent might script actions in Selenium, Playwright, or even produce YAML WebDriver tests. Shiplight produces a .test.yaml file. Some agents are language agnostic. TestForge, for example, advertises support for any language, Python, JavaScript, Java, etc. The key is that developers can review the generated tests as code reviews, just like human-written tests, since they live in the repository. Issue trackers, defect filing. When a generated test fails, some platforms automate bug filing. For instance, TestSigma's bug reporter agent can analyze a failed test step and create a Jira ticket with all details: error type, root cause, recommended fixes, screenshots, and repro steps. This ensures that failures discovered by the agent result in actionable defect tickets. Likewise, an agent could be configured to post a failure report to GitHub Issues or Jira, complete with logs and context captured during testing. This bridges automated testing and bug tracking, saving QA teams from manually reproducing failures. Coverage gains with AI-generated tests. One of the main selling points of AI testing agents is enhanced test coverage. By rapidly generating tests, agents can cover many branches and edge cases that might be missed otherwise. Numerous vendors quote impressive coverage improvements, dramatic savings in effort. NVIDIA reports that its internal AI test generator, HEPH, saves up to 10 weeks of development time of manual testing work. Similarly, DiffBlue recounts a case where 3,000 unit tests, doubling coverage, were created in 8 hours, a task that would have taken roughly 268 days by hand. Doubling coverage, even before any refactoring, suggests enormous baseline gains. Higher baseline coverage, agents can automatically fill coverage gaps. Kodakov's marketing page even suggests their AI can get your PR to 100% test coverage by writing unit tests for you. In practice, this means any new or changed lines in a pull request are targeted by generated tests. A benchmark from DiffBlue claimed their agent delivered 20 times more code coverage than leading LLM coding tools because it could run unattended and stitch together existing test assets. Continuous improvement. Agents often critique themselves. For example, NVIDIA's HEP framework compiles and runs each generated test, gathers coverage data, and then iteratively repeats generation for the missing cases. DiffBlue's new guided coverage improvement feature even prioritizes low coverage areas and can boost coverage by another 50% beyond the initial pass in just 1 hour. Such feedback loops keep the overall test suite growing as the product evolves. Overall, AI agents can execute a shallow-first strategy. They rapidly produce a wide breadth of tests, especially for common happy paths, raising overall coverage. That said, edge case coverage still needs careful direction. See risk section, but the net effect reported by companies is clear: much higher coverage and fewer blind spots, achieved with far less manual scripting. Reducing flaky tests. Flaky tests, those that sometimes pass and sometimes fail without code changes, are a bane of CI pipelines. AI can help reduce flakiness in several ways. Smarter locators and weights. Many test failures come from UI elements changing or being slow to load. Simple automation scripts often hard code selectors and fixed weights. AI agents, by contrast, can use context-aware locators. For example, Shiplight's agent identifies elements by intent, like add item to cart in the YAML test, rather than brittle CSS paths. Zoff.ai automatically updates tests when minor UI changes occur. automatic selector updates. QA Wolf's research shows that broken locators cause only about 28% of failures. The rest are timing issues, data problems, runtime errors, etc. Effective self-healing addresses all categories, e.g., adding waits for async loads, reseeding test data, isolating errors, or inserting missing UI interactions. By diagnosing fail causes instead of blindly patching, AI can prevent flaky false positives and preserve the intent of each test. Continuous maintenance. Because agents generate tests as code changes, flaky conditions can be nipped at the bud. An agent can rerun suites routinely and catch transient failures early. If flakiness is detected, e.g., a test fails randomly, the agent's maintenance phase can attempt fixes or quarantine that test. For example, platforms like TestMu, formerly Lambda Test, offer flaky test detection that identifies unstable tests and advises engineers which to fix or skip. While not fully automatic, AI integrations could allow the agent to incorporate such analytics. Less human error. Manual tests often become flaky because of copy-paste errors or anti-patterns. AI-generated tests, especially when re-verified in a real environment, tend to be cleaner. Agent-first approaches, where the agent opens the browser and includes actual user interactions as assertions, ensure tests reflect real behavior. This reduces the false confidence of a script passing by chance. In practice, teams using AI testing agents often see far fewer broken tests. NVIDIA's platform even asserts that each test is compiled, executed, and verified for correctness during generation, meaning only valid tests make it into the suite. Advanced agents give full audit trails of how they fixed each failure, which also helps QA teams spot problems. Overall, by leveraging self-healing and thorough analysis, AI-driven QA can dramatically reduce flaky failures and keep CI builds green. Speeding up release cycles. By automating churn-intensive QA tasks, agencies cut cycle time. Immediate test creation. Traditional workflow. A developer writes code, opens a PR, then QA engineers take hours or days to script tests and run them. AI flips this model. In agent-first testing, the same AI that wrote a code change also verifies it on the fly. Shiplight describes how its agent writes code, opens a real browser, verifies the change works, and saves the verification as a test, all in one loop without leaving the development session. This means tests exist even before a PR is opened. The code plus test move together, so code review and testing happen simultaneously. Such parallelism collapses delays. The time between code being written and code being tested shrinks from days to minutes. Continuous integration with no lag. When tests auto-run on each commit, feedback is immediate. ZOF.ai and similar tools offer real-time execution logs and run tests on every push. Developers get instant results or failure alerts, eliminating the idle wait for a manual QA cycle. This accelerates the entire merge process, enabling fast feature velocity. Because AI agents can crank out far more tests than a human team, they avoid creating a QA bottleneck. Shiplight notes that agents generate 10 to 20 times more code changes per day than traditional developers, meaning manual testing becomes the slow step if not automated. Agent-first QA keeps pace. Tests scale with the agent's speed. DiffBlue similarly reports that its agent can be left unattended to generate coverage for hours on large code bases, while LLM-based tools needed constant prompting and supervision. In benchmarks, DiffBlue's unattended agent delivered 20 times more coverage versus Copilot or Claude, largely because it did not require human reprompting. The net effect is fewer release delays. With agents, even small fixes or new features are shipped with safety checks already done. Developers can focus on coding, knowing the AI is continuously testing behind the scenes. In practice, teams using such tools report significant time savings. In one NVIDIA trial, engineering teams saved up to 10 weeks of development time by offloading testing work to AI. Risks in ground-truthing AI-generated tests. AI QA agents are powerful, but they bring new risks. The biggest danger is misalignment between tests and true requirements. Overfitting to existing code. An AI might generate tests that merely reflect the current implementation rather than validating the intended behavior. If the code and spec diverge or the spec is flawed, the agent's tests will faithfully overfit the code's current logic. As TechRadar warns, fully autonomous generation can misread business rules, skip edge cases, or collide with existing architectures, producing tests that look plausible but miss important requirements. For example, if an AI only sees the happy path code for a feature, it might not test error conditions. Similarly, an LLM-based agent might hallucinate a feature not actually specified. A study noted that some LLM code generation can introduce subtle bugs, so test agents must be just as cautious. Hallucinations and drift. Language models sometimes fabricate or fill in gaps incorrectly. In a testing context, this could mean generating assertions not grounded in spec. If unchecked, this leads to technical debt in tests, a false sense of coverage. Researchers have found that more advanced AI models can still produce incoherent results on complex tasks. Hence, AI test results must be taken with skepticism. The tests should be treated like drafts requiring human review, not final answers. To combat these risks, ground truthing against the specification is essential. Traceability to requirements. One solution is to tie each test back to a concrete requirement or user story. NVIDIA's HEPH framework exemplifies this. It retrieves a specific requirement ID from a system like Java, traces it to architecture docs, and then generates both positive and negative test specs to cover that requirement fully. By linking tests to requirements, we ensure coverage is measured against the spec, not just the code. If a test fails, it can be checked. Does this reflect a deviation from the requirement or a bug? Bidirectional verification. After generating tests, another AI or rule-based system can check that the tests satisfy all acceptance criteria. For example, having the agent produce a natural language summary of what each test asserts, with links to spec sections, allows a human or automated checker to confirm completeness. Some propose using two models in tandem. One writes the test, the other explains it back to the spec. Any discrepancies signal a need for refinement. Human in the loop, HITL, as TechRadar emphasizes, AI should augment testers, not replace them. Clear processes and guardrails are vital. Specify formats, use templates, and mandate that no test is merged without human approval. Treat AI outputs like a junior analyst draft. Require context up front, check negatives and boundaries, and keep an audit trail. In practice, this means QA engineers review AI-generated test plans, refine prompts, and validate that each test corresponds to a real requirement. Checking AI diffs, changes an agent made, against intended flows helps catch hallucinated or irrelevant steps. Coverage auditing. Incorporate automated coverage metrics and code analysis to flag tests that only cover trivial paths. If certain spec items remain untested, the agent should be tasked to generate missing cases. Tools like CodeCov or SonarCube can highlight untested requirements or risk areas. An advanced agent might even scan test coverage reports and automatically backfill gaps, as DiffBlue's guided coverage does by prioritizing low-coverage functions. Security and compliance checks. Many organizations require data and model governance. Ensure the AI agent respects non-disclosure boundaries, no leaking proprietary code to external LLMs, and follows code review policies. For regulated fields, keep an audit log of AI activity. In summary, the strategy is context plus review. Feed the agent official specs, guard its outputs, and verify coverage analytically. When done carefully, AI can amplify QA speed without sacrificing correctness. When done carelessly, it risks shipping defective test suites. Examples of AI QA tools and approaches. Several companies and open projects are building this vision. DiffBlue Cover Agents, Oxford, UK, AI for unit testing in Java Kotlin. Cover uses reinforcement learning to write comprehensive unit tests. It integrates as an IntelliJ plugin, CLI, or CI step. Cover is reported to drastically speed up coverage. 3,000 tests in 8 hours, doubling coverage. Its newer testing agent can run unattended to regenerate entire test suites and even do gap analysis. DiffBlue's benchmarks claim their agent generates 20 times more coverage than LLM-based assistants, since it can run in agent mode without constant prompting. Cover annotations also label tests, human versus AI, to manage maintenance. Shiplight AI USA, agent first testing. Their model makes the AI code writing agent also perform verification in browser instantly. In practice, as an agent writes a new UI feature, it will open a browser, exercise the flow, assert outcomes, verify statements, and then save that as a YAML test file in the repo. This means tests are authored during development, not after. The approach emphasizes human-readable, intent-based tests that self-heal with UI changes. Shiplight demonstrates that QA shifts from a separate end-of-cycle gate to being built into the coding loop. Their stack layers include instant in-session verification, gated PR smoke tests, full regression suite, and automated test maintenance. Zoff.ai USA offers autonomous testing agents as a service. You connect your repository, public or private, via OAuth, choose from dozens of test types, unit, integration, UI, security, performance, etc., and Zoff's agents generate tests accordingly. It supports scheduling on every commit with CI integrations. Notably, Zoff advertises self-healing. UI tests auto-update when minor changes occur. It also provides real-time analytics and video recordings of test runs. Essentially, Zoff packages agent generation, execution, and maintenance in one platform. TestSprite USA is a newer platform, 2026, focused on AI-driven end-to-end testing. Their blog describes the stages of an AI testing agent. First, it parses specs, documents or code to learn what the app should do, then generates prioritized test flows, runs them, and even closes the loop by recommending fixes for real bugs. TestSprite's agent also maintains a knowledge base of requirements. They emphasize that traditional scripts are brittle and human-bound, whereas their agent works at a higher level of abstraction. The agent then writes Playwright/Selenium tests for user journeys, API calls, etc. TestSigma USA combines AI-assisted test creation with an analyzer agent. QA teams can click a UI element in a failed test, ask the analyzer to inspect it, and then have a bug reporter agent file a ticket. TestSigma's system automatically captures everything needed for a bug, error details, recommended fixes, screenshots, and logs it into Jira or other trackers. This illustrates how AI can automate the defect triage step, from test failure to issue in minutes. TestForge, community project, is an open-source prototype via JMM Entertainment that hints at a DevOps-friendly workflow. TestForge's site offers an npx TestForge CLI that scaffolds tests for any repo, connects to CI, and generates LLM-powered blueprints for unit integration tests. It touts 10 times faster coverage by prioritizing critical paths and even includes mutation testing to spot weak areas. It also provides a live dashboard for pass rates and flaky tests. Whether it's mature is unclear, but it represents the direction of automated multi-language test generation. CodeCov, now part of Sentry, is known for code coverage reports, and it has begun offering AI features. Its marketing materials claim the platform uses AI to generate unit tests and review pull requests. It flags flaky or failing tests and suggests which lines to focus on. CodeCov's interface adds coverage comments on PRs and works with any CI and numerous languages. It exemplifies integrating AI-driven test feedback directly into developers' workflows. These examples show that solutions span from highly specialized, unit test only, to broad platforms end-to-end testing. They all share one thing: linking testing tightly to code and dev processes. Gaps and opportunities for next-gen solutions. While the current tools are powerful, there are still unmet needs. Spec-driven ground truth. Most existing agents focus on code intelligence. Few truly ensure every generated test aligns with formal requirements. A next-generation solution could explicitly link tests to each requirement or user story. For example, embedding requirement IDs or document excerpts in test metadata would allow engineers to audit exactly which spec item each test covers. Entrepreneurs could build a platform that enforces bidirectional traceability. For every requirement entry in a backlog or Confluence, the system tracks that at least one passing test covers it. This would nearly eliminate the overfitting risk by design. Explainable test generation. Current LLM-based tools often function as black boxes. An improved system might generate not just tests, but also clear natural language rationales and citations for every test step. For example, when an agent creates an assertion, it could attach the relevant sentence from the spec or a user story. This transparency would make it easier for human reviewers to verify correctness, as suggested in Tech Radar's advice to have AI explain its rationale. Unified multi-layer testing agent. Many products specialize in one layer of testing, unit or UI or API. A gap exists for an end-to-end agent that comprehensively tests across layers. Imagine an open-source meta agent that can generate unit tests, API contract tests, and UI end-to-end flows in one coordinated suite, driven by a single coherent understanding of the app. It could share telemetry, e.g. coverage environment, across layers and optimize test portfolio holistically. Continuous learning from production data. Few QA agents today use production telemetry to refine tests. A novel solution could monitor real user behavior or error logs, detect untested conditions seen in production, and push new test scenarios to cover them. This would close the loop between deployment and QA, making agent-driven testing truly continuous. Security and compliance auditing. As AI QA agents adopt code and data to train test, enterprises may want built-in compliance checks. A business opportunity is a platform that tracks data flows and tests and ensures no sensitive info is leaked, or that created tests meet regulatory audit requirements, especially in finance or healthcare. SME, subject matter expert tuning. Current agents often lack domain context. Tools that let domain experts teach the agent via a guided interface, feeding specific edge cases, business rules, security constraints, could yield much higher quality tests. For example, a form where QA defines critical flows and the agent then validates coverage of those specifics. In sum, entrepreneurs could look beyond raw test generation and into process orchestration, a solution that integrates specification management, AI test creation, continuous validation, and compliance. The goal: trustable, requirement-driven QA that keeps pace with agile delivery. The foundation exists, but there's room to unify and refine these capabilities into even more powerful platforms. Conclusion: AI-powered QA agents promise a seismic shift in software testing. By reading requirements, auto-generating tests, and keeping them updated, they can skyrocket coverage and slash QA cycle times. Integrated deeply with code repos, CI/CD, and issue trackers, they make testing a seamless part of development. Early adopters report dramatic productivity gains, DiffBlue's 20 times coverage claim, NVIDIA's 10-week time savings, and so on. However, this new frontier also demands new guardrails. Without careful oversight, AI-generated tests can hallucinate or simply mirror the code without verifying true user needs. Best practices will be vital. Tie tests back to specs, require human review of AI drafts, and use analytics to spot coverage gaps. Emphasizing explainability and traceability can turn the AI agents from mysterious black boxes into trustworthy assistants. The field is young and evolving fast. The tools cited here, DiffBlue, Shiplight, Zoth, TestSprite, and others, represent just the beginning. There are clear opportunities for innovation, better spec grounding, unified all-in-one pipelines, and more transparent learning agents. As those gaps are filled, we can expect even more radical shifts in QA. Ultimately, the goal is clear: release higher quality software faster. AI agents are helping make that real. With prudent use and continued invention, they will soon be indispensable members of every DevOps team's toolkit. All links to sources are available in the text version of this article. You can find the full article at aiagentstore.ai/agentic AI and workflow automation. Thanks for listening. And thanks for rating the show. Visit aiagentstore.ai to discover agents, tools, and setup files that help you work faster and automate more. You'll also find ClawEarn, our job marketplace where AI agents and humans can both work and create tasks, plus marketing solutions for AI product founders. Explore it all at aiagentstore.ai.